The difference of today's lesson from yesterday's lesson is that in yesterday's lesson, we had our functions and we were doing operations, adding, subtracting, multiplying, dividing them, and we were getting a number as an answer. What we're going to do today is we're still going to use the operations of add, subtract, multiply, and divide, but this time we're just using variables. So we won't just get a number as an answer, we will get some kind of an expression as an answer. So here's our first one. We're going to be using f of x, g of x, and h of x the whole way through these notes. I have them listed there so you guys don't have to keep rewriting them down. But we're using those three functions and then just doing the examples 1 through 6. So for example number 1, it says f of x plus h of x. So I'm going to look at my f of x. F of x is x squared plus 2. Plus h of x is x plus 1. What can I add together there? Corey?
You can add together 2 and 1 to get 3.
Yes. And guess what? That's it. We combined our like terms. The constant terms were the only like terms that we had. So you just leave it as x squared plus x plus 3. G of x minus h of x. So look at g of x, it's 4x. Minus h of x, now we want to subtract that whole function, x plus 1. It's very important that I put that in parentheses. Why? I'm subtracting that whole quantity, and what happens with that subtraction sign? That's outside of the parentheses. Go ahead, Corey. Yes. That negative sign is like a -1, and that needs to be distributed to both parts of that quantity. So we have 4x minus x minus 1. Simplify by combining the like terms. What is the simplified answer here? Lenny?
3x minus 1.
Very good. Third example, f of x, which is x squared plus 2, times g of x, which is 4x. Use parentheses. They will help you. Now, what if I had something like 4 times x squared plus 2? What would I have to do to simplify that? What would all of you guys do if you had to simplify that? Maddie?
4x squared plus 8.
Right, you would do what to the 4? You distribute it. Guess what? This is no different when we're multiplying x squared plus 2 times 4x. It just looks a little bit different. We still have to distribute, but we're distributing backwards compared to what we usually do. But you need to multiply that whole quantity by the 4x. That's why we have to distribute it. So 4x times x squared is 4x cubed. 4x times 2 is 8x. Can I combine those? Can I combine 4x squared, or I'm sorry, 4x cubed and 8x? Maddie? No, absolutely not. Those exponents are not the same on the x, so you can't combine it. That's all we can do. Then we have h of x divided by f of x. H of x is x plus 1. Divided by, make it a division bar. f of x is x squared plus 2. Can I simplify that in any way? Lenny?
The 1 and 2.
Oh, no, I can't.
No?
I cannot. I could if it was just 1 over 2 or 1x over 2x. Then I could say, oh, that's just 1/2, and I could cancel out my x's. But hey, we're adding here. That addition means that I just can't start crossing things out. They have to have a common factor to all the terms in this fraction. And nothing shares a common factor through each of those 4 terms. So you can't cross anything out. You can't cancel anything. Guess what? We're done. Yeah, that's an easy one. Ooh, now the fun begins. H of x is x plus 1 times f of x, x squared plus 2. This is multiplying 2 binomials. Anybody remember how we multiply 2 binomials? Rachel? Yes, you do, Foil. Our friend Foil is back. First terms, x times x squared is x cubed. Remember, if you have the same base, you add the exponents. Outer terms, x times 2 is 2x. Inner terms, 1 times x squared is x squared. And the last terms, 1 times 2, 2. Lenny.
Is it now plus or still multiplication or additional multiplication?
You're multiplying each of those terms. So a positive and a positive gives you another positive. Can I combine anything here? Kyra, did you change your mind? Okay. Corey?
Can you put x to the 5th power?
No, you cannot. If you were multiplying them, you could put x to the 5th, but you can't add them. Lenny?
You said you're multiplying.
You're multiplying right here. This step is multiplication, and now right here, we're just adding. Then no. Right. You cannot. The only time you can add is when you have the same base and the same exponent. Remember, like terms are the same variable and the same exponent. And none of these variables have the same exponent. Maddie? That's your answer. That's it. Now, in standard form, it would be x to the 3rd plus x squared plus 2x plus 2. Because you want to go from the highest exponent and then in decreasing order. I'm not going to mark it wrong if you don't have it in standard form, because we haven't really talked about that to this point, but that is how you would most commonly see your answer written. Example 6, g of x is 4x minus f of x, which is x squared plus 2. What do I need to do here? Maddie? Yes, you must distribute the negative outside the parentheses. Minus x squared minus 2. Now, if you get to that point, that's great, because that's your answer. We cannot combine any like terms because there are no like terms. Could somebody rewrite that, though, in standard form for me? Somebody want to try that for me? Maggie?
X squared minus 4x. Oh, wait, plus 4x?
Okay.
Minus 2.
Almost perfect. Check out your x squared. What are we missing from x squared?
Oh, negative.
Negative, yes. Always take the sign in front of it. So that would be the standard form. Now remember, if you were to use a different variable than x, say in number 4 we used h of a divided by f of a, it is still the exact same concept, except for this one, when you would use h of a, you would put a in your function h, so you would have a plus 1. Divided by f of a, you just put a in as your input for function f, and you would have a squared plus 2. So you can do this with any variables. We used x's, but you could use any variable that you want.